Prologue. What we call value. We are used to linking value with complexity, with rarity, with things that are hard to obtain or reproduce. We assume that importance must be visible, must stand out, must look impressive. But one of the most important materials in human history looks extremely simple: a white crystal, with no obvious signs of value, no decoration, no external complexity. That substance is salt. Scientifically, salt is sodium chloride, NaCl, one of the simplest and most stable crystal structures known to us. The same crystal exists everywhere on Earth, in the sea, in the mountains, and deep underground. And yet, its role is far greater than its appearance suggests. Without salt, there would be no food preservation, no development of cities, no stable life processes in the body. To understand why such a simple crystal became fundamental for life and civilization, we need to begin with its structure. Chapter 1: The Structure of Salt. Order instead of chaos. Scientifically, salt is sodium chloride, NaCl. But the formula itself is not the key point. What truly matters is how this substance is built. Salt belongs to ionic crystals, materials in which particles are arranged not randomly, but in strict order. A sodium atom gives up an electron. A chlorine atom accepts it. As a result, ions form with opposite charges. These ions attract each other and create a stable structure, where every element has a precise position. This creates the crystal lattice of salt. It repeats itself again and again, without distortion, without chaos. That is why salt crystals have a consistent shape, most often cubic. This shape does not depend on where the salt was formed. Salt remains the same, whether it is extracted from seawater, mined underground, or formed millions of years ago in ancient deposits. Very few substances in nature have this level of stability, and that stability is essential. It creates a predictable environment where complex processes can exist. Living systems cannot function in chaos. Cells and tissues require stable physical conditions. The simplicity and reliability of salt structure made it fundamental to the processes of life. Chapter 2: Salt and the Oceans. Salt and water on Earth are inseparable. To understand salt in nature, we must begin with the oceans. Modern oceans are salty not because salt was added to them, but because over millions of years, a natural process gradually accumulated dissolved minerals. When rain and rivers erode rocks, they carry dissolved salts with them. These salts, together with fresh water, flow into seas and oceans. Water evaporates, but salts remain. This process repeated countless times, slowly shaping ocean salinity. Salinity is not evenly distributed. It depends on climate, temperature, and water exchange. The Atlantic Ocean, on average, is saltier than the Pacific because evaporation is stronger and freshwater inflow is lower. The Red Sea is even saltier due to hot climate and limited exchange with open ocean. An extreme example is the Dead Sea, where salt concentration is so high that most forms of life cannot survive. The Dead Sea shows what happens when evaporation greatly exceeds water inflow. Salt accumulates, water disappears. It is a natural but extreme case. And yet, the oceans do not become infinitely salty. Some salts precipitate over time, forming salt rocks. Others enter geological cycles and move with Earth's crust. Ocean salinity is not an accident. It is the result of a long balance between mineral input, water evaporation, and geological redistribution. And within this salty environment, processes developed that later became essential for human life. Chapter 3: Salt in Human History. Today's salt deposits are traces of ancient seas. Millions of years ago, where we now see mountains, plains, and deserts, there were oceans. Over time, climate changed, water retreated, and evaporated, leaving salt behind. Layers formed, covered by other rocks, creating underground deposits. That is why salt can be found far from the sea, deep underground, in mountains and in dry regions. Humans did not invent salt. They encountered it as an existing resource and learned to use it. In ancient China, systematic salt production began thousands of years ago. Saltwater sources were used, and primitive wells were drilled. The water was evaporated, leaving salt crystals behind. In Mesopotamia and ancient Egypt, salt was essential for preserving fish and meat. In hot climates, this was a matter of survival. In the Roman Empire, salt became a state resource. Special roads were built, including the Via Salaria, to transport salt to cities and armies. Later, salt mines appeared, where rock salt was extracted directly. Today, salt is produced by evaporating seawater, mining rock salt, or using vacuum methods to create highly pure salt. Chapter 4. Food Preservation, Osmosis and Stability. Salt has a rare property. It practically does not change over time. Its crystalline structure remains stable regardless of environmental conditions. Salt does not rot, does not oxidize, and does not break down in the way organic substances do. When humans began using salt to treat food, they noticed a simple effect. Food lasted longer. Meat, fish, and vegetables spoiled more slowly and maintained their structure for weeks and even months. This effect was observed long before the rise of modern science. The reason for this phenomenon lies not in chemistry, but in physics. Salt reduces the water activity of food. It draws moisture out of the cells of microorganisms, removing the environment necessary for their survival and reproduction. Without water, bacteria and many types of fungi cannot maintain their life processes. When salt deprives them of moisture, the growth of microorganisms stops, and food no longer spoils quickly. This mechanism is known as osmosis. Because of this property, salting became the first universal technology for food preservation. Long before refrigerators, chemical preservatives, or thermal processing, salt made it possible to create long-term reserves. Such reserves were crucial for survival. They allowed people to endure winters, droughts, and long journeys. Without salt, seafaring, long-distance trade, and the supply of remote settlements would not have been possible. Thus, salt became not just part of the diet, but the foundation of food stability. It allowed humanity to move beyond seasonal survival and to build more stable forms of society based on reserves rather than on chance. Chapter 5. Salt in Medicine. The first universal tool. The same properties of salt that protected food from spoilage also proved useful in treatment. Long before people understood bacteria, salt was already used to treat wounds and injuries. Wounds were washed with salt water, and salt compresses were applied to inflamed areas. Such practices existed in ancient Egypt, in classical Greece, in Rome, and in traditional medicine across Asia. People did not understand what exactly caused infections, but they observed the results. Wounds treated with salt became inflamed less often and healed more quickly. This experience was passed down from generation to generation. The reason for this effect was the same as in food preservation. Salt disrupts the internal balance of microorganisms. It draws moisture out of their cells and creates an environment in which they cannot survive. At the same time, salt does not destroy human tissue and does not act as a chemical poison. It works through physical processes, without interfering with the structure of living cells. This is what made it a relatively safe remedy. Seawater was also used for medical purposes. It was applied to wash wounds, to cleanse the skin, and to treat mucous membranes. These methods were based not on theory, but on practical observation. Over time, these observations formed the basis of a more systematic approach. Modern saline solutions used in medicine today are based on the same principles of salt balance. Thus, salt became one of the first universal medical tools. It was used long before microbiology and antibiotics, yet it worked consistently and predictably. Chapter 6: Salt as a Strategic Resource of Civilizations. For most of human history, value was defined not by rarity or beauty, but by the ability to survive. In this sense, salt was for a long time more important than gold. Gold did not save people from hunger, and did not allow food to be stored. Salt did. Without salt, it was impossible to create long-term reserves. And without reserves, people could not survive winter, drought, or siege. Control over salt meant control over food, and therefore control over human life. That is why salt quickly became an object of state control. In ancient China, a state monopoly on salt existed for more than 2,000 years. Revenue from it made up a significant part of the treasury and was used to support the army and govern territories. In the Roman Empire, salt had strategic importance. Special roads were built to transport it. One of them, the Via Salaria, connected salt-producing regions with Rome. The supply of cities and the combat readiness of the legions depended on a steady flow of salt. In medieval Europe, access to salt was also strictly regulated. In France, there was a salt tax, the gabelle. It was so burdensome that it caused widespread dissatisfaction and salt-related uprisings in various regions of the country. Salt was also used as a form of payment. The Latin word salarium referred to compensation associated with salt. From it came the modern word salary. This reflects the reality of an era in which salt was a condition of survival, not a luxury item. Thus, salt was valued not for its external rarity, but for its function. It ensured food preservation, the stability of armies, and the endurance of societies. In this sense, its importance truly surpassed that of gold. Chapter 7: Salt in the Human Body. Ion balance and electrical regulation. The role of salt in the human body is not related to taste or eating habits. It is connected to fundamental processes that allow the body to function. Sodium is the primary ion involved in transmitting electrical signals through the nervous system. Every nerve impulse, every muscle contraction, and every heartbeat depends on the movement of sodium and potassium ions across cell membranes. This process creates a membrane potential, a difference in electrical charge, without which cells cannot communicate. Salt also regulates the distribution of water in the body. It determines how much fluid remains in the bloodstream and how much moves into tissues. This balance is maintained by the kidneys and the hormonal system, which constantly adjusts to environmental conditions. When the level of salt in the body becomes too low, a condition known as hyponatremia develops. In this state, the transmission of nerve signals is disrupted, cells begin to accumulate water, and symptoms appear: weakness, confusion, and seizures. Such conditions are well known in sports medicine. There have been documented cases where during prolonged exertion, people consumed large amounts of water, but did not replenish electrolytes. As a result, the danger was not dehydration, but the disturbance of salt balance. Excess salt also places stress on regulatory systems. When too much sodium enters the body, it retains water to preserve concentration balance. This increases the load on the kidneys and blood vessels, especially when adaptive mechanisms are impaired. It is important to understand that salt does not directly cause high blood pressure. Risks arise when compensatory mechanisms are disrupted. Salt itself is neither poison nor medicine. Salt is an element of a system. It requires precise regulation, not extremes. When balance is maintained, the body functions steadily. When it is lost, problems arise, not because of salt itself, but because equilibrium has been disturbed. Final, salt as an element of systemic balance. Salt is a substance that connects several levels of reality. It exists as a natural crystal, as part of the oceans, as a resource of civilizations, and as a component of living systems. It cannot be reduced only to food or only to human use. Salt does not create life and does not control it directly. But without it, living systems lose stability. It defines the boundaries within which order, balance, and structural consistency are possible. We have stopped noticing salt precisely because it is always present. But the most fundamental elements rarely appear impressive. Their value is not expressed through appearance, but through the function they perform. When we look at salt at this scale, it becomes clear. It is not about taste and not about habit. Salt is not a seasoning. It is one of the basic elements on which life itself is sustained.